In this video, we show the footage of the experiments involving the 4 different H-ModQuad structures presented in the experiment section of the manuscript. We will explain the behaviors of the structures with the plots. In the first experiment, the structure of one R module follows a helix-like trajectory, which varies along x, y, and z translational axes with independent sinusoidal patterns, and linearly increases the angle along the yaw rotational axis with regard to the time. In the second experiment, the structure of 2 R modules follows a rectangular trajectory which spans along x and y translational axes for 0.8 and 0.6 meters. We highlight that in A, the structure keeps a pitch angle of -5 degrees, and in B, the same structure keeps a pitch angle of 0 degrees, showing that its translation along the x-axis is independent of the pitch angle. In the third experiment, the structure of 4 R modules follows a rectangular trajectory which spans along x and y translational axes for 0.8 and 0.6 meters. The structure keeps both roll and pitch angle at 0 degree during the translation, showing its independence of translational motion from rotation. In the fourth experiment, the structure of 4 T modules keeps hovering in place and follows a sinusoidal pitch angle with regard to the time, showing its independence of rotational motion from translation. Since the structure is central symmetric, the same behavior can be achieved along the roll rotational axis as well. In the fifth experiment, we try to make the same structure as in the fourth experiment tilt along its pitch angle to its maximum capability by changing the desired pitch angle manually. As shown in the footage, the maximum pitch angle is around 38 degrees. Despite the relatively large errors along translational axis, the structure still manages to keep hovering in place. If the desired pitch angle goes beyond the structure's capacity, some motors will shut down, indicating the constraint of the unidirectional motors is affecting its performance and stability. In the sixth experiment, the same structure as in the fourth experiment follows a rectangular trajectory which spans along x and y translational axes for 0.8 and 0.6 meters. The structure keeps both roll and pitch angles at 0 degrees during the translation, showing its independence of translational motion from rotation. Combined with the fourth experiment, it shows in complete detail that the structure is fully actuated. We show the footage of the simulations in Coppelia Sim involving the 3 different H-ModQuad structures presented in the simulation section of the manuscript. We demonstrate the scalability of our controller. In all 3 simulations, the structures follow Puntic polynomial trajectories that are slightly different from each other. In each simulation environment, in addition to an H-ModQuad structure, we also place a transparent cube to show the desired pose for the structure. In the first simulation, the 4x4 structure is composed of 16 T modules. We create the structure such that the connections between modules are not completely rigid to reflect the possible structural disturbance in practice. In the second simulation, the 3x3 structure is composed of 5 T modules in the center and 4 corners of the structure, and 4 R modules on the 4 sides. In the third simulation, the plus-shaped structure is composed of 3 T modules in one column and 2 R modules on the wings. We highlight that this structure has a non-identity rotation matrix from the S frame to the F frame.